Hi, in this one, I'm going to cover up the basic concepts of nth root of a polynomial, nth root of any complex number. And uh, obviously, I'm going to take some IB questions and demonstrate them. So first, let me begin up what exactly are the type of question that I'm going to cover. So let's say here is a complex number that you're raising to the power n, raising to the power 3 here. So I'm getting the answer as -1 plus I. Now, what I really want to find out is, I want to find out what is this complex number. So obviously, if I can see that, if I can clearly understand the basic operations, I can rewrite that it as z is -1 plus I to the power 1/3, right? So how do I get the answers? Which are the possible answers for this? So that's the objective of this lesson. I'm going to explain firstly how do we do it, understanding the basics of the nth root of a complex number. So every complex number that is in Cartesian form, that is your a plus bi, firstly must be written as uh, in the r cis theta form, that is your polar form. So when you write down a complex number in r cis theta form, then it simplifies half of your task, and you can apply the basic concepts of de Moivre's theorem. Now, let me just take this example. So first what I'm going to do is, I'm going to write down the z cube equals to -1 plus I. So I'm going to write down -1 plus I as in r cis theta form. Now, as we all know that the modulus of the complex number is 1 square plus 1 square here. So you can take -1 square, that's still the same thing. So modulus of the complex number that I can clearly see is square of 2. And coming back to the principal argument, first I want to see which quadrant is the complex number in. So the complex number is in quadrant number 2, because your real part is negative and your imaginary part is positive. So that's this length is your 1 unit and this length is your 1 unit. I haven't shown any negative sign here because I'm just taking this as a length of the complex number here. Then length of the real axis distance. Now, after this, what I'm going to do is I'm going to first calculate this angle. So if you see that, okay, tan theta is 1/1, which is nothing but pi/4 I can do. So this tan theta is 1/1. So that gives me theta as pi/4. So once we got this angle, now my principal angle is always taken with reference to the positive x-axis. Okay, when you take with the positive x-axis, and you know that the measurement for principal argument has the rule that capital ARG of any complex number is between -pi to +pi. Okay, so the principal argument we have to be a little careful about the -pi to +pi. Now, once you've written the complex number in r cis theta form, so that is your square root of 2 cis 3 pi/4. Now, when you write down in square root of 3 pi/4, then our next question is that how do I go ahead about finding the complex numbers that gives me this answer if I raise to 3. Okay, so now here is your de Moivre's theorem, because we got to have the prior knowledge of this first before I do this particular thing. So if you z to the power n is r cis theta, and of course when I raise to the when I bring this n to the other side, it is going to be something like this. Now z is r to the power 1 over n cis theta over n. Now this is going to give you only one angle. This is going to give you only one answer, because n is going to be fixed, theta is going to be fixed. So what are we going to use in order to get the values of the other complex number? So what I'm going to do is I'm going to use the periodic property of sine and cos, and because we know the sine and cos both are periodic, so I can, for example, I can write down, let's say if it is theta here, if there is a complex number that is with a theta here, so I can say that, okay, if this is theta, now even 2 pi plus theta is going to have the same measurement. So 2 pi plus theta is going to have the same measurement here as well. So 2 pi plus theta, when I talk about, it's still the same angle. So what I do is I basically take 2 pi plus theta as in general as 2 pi k plus theta. So you can put k as 0, k as 1, k as 2, k as 3, and so on. And you can get the possible same complex number. So now this is my formula, which I highly recommend my kids to remember this. So if you have a complex number, z is r cis theta, then z to the power n is r cis theta, then z is nothing but r to the power 1 by n cis 2 pi k plus theta by n. Simple. We are using the de Moivre's theorem property. Okay, so when you raise a complex number to the power 1 by n, this modulus get raised to power 1 by n, an argument get multiplied by 1 by n, which is this. Now, because I'm writing argument, because of periodic nature of sine and cosine, so this is divided by entirely by n. Now let's see how do we put this in our context in this problem. So just comparing both of these, so I have written this part pretty similar to what I have done for the above complex numbers. So this is r is nothing but root 2 that gets substituted here, and 2 pi k plus theta. So theta is 3 pi by 4 over 3. Now, what you have to do is you put k as 0, 1, and up till, like, suppose if I have three roots that I have to find. So put k as 0, k as 1, and k as 2. Okay, so you can clearly see when I put k as 0, I get, this becomes 0. So I get 3 pi by 4 divided by 3, which is pi by 4. So that's my first answer. Now, when I put k as 1, I get the second answer. So that is your root 2 to the power 1/3 cis 11 pi by 12. When I put k as 2, I get root 2 to the power 1/3, which is going to be the same because not related to k, and I get cis 19 pi by 12. So this is how you find out the three possible complex numbers that would, if you raise to the power 3, you're going to get the answer as -1 plus I. Now, sometimes you might have to convert this general argument into the principal argument, so that you need to know. So for example, if I do 19 pi by 12, it is going to be somewhere here, that is in this quadrant. Now, obviously, I can't take this angle as my principal argument. So this angle is the principal argument here. So suppose, let's say 11 pi by 12 is here. So how can I find out this angle? So you can just do 2 pi minus this to get the answer. So this is going to be, if I do 2 pi minus the 19 pi by 12, so it is 24 minus 19. So 5 pi by 12. So this is here. 5 pi by 12 is this answer. But this has to be written negative because you are considering a clockwise motion. So any angle that is taken clockwise, you will have negative argument, and any angle that goes clockwise, anti-clockwise, that will have positive argument. So this is positive theta, and this is negative theta. So this is how you find out the complex numbers in um, uh, the nth root of complex number. So firstly, like, what is the critical observation? Now, when I plot these complex number along a circle, so if I can first show these three complex numbers, like root 2 to the power 1/3 cis pi by 4, then it is this second complex number that you got, root 2 to the power 1/3 cis 11 pi by 12, and the third one is root 2 to the power 1/3 cis 19 pi by 12. Now these are like spokes of the wheel. Okay, so now we can simply join these from here. Then you can see if I join from here and then join here. Now these are equally spaced, so obviously this angle then becomes 120 degrees. So equally, this angle is 120, this angle is 120. So what happened is that it's actually looking like an equilateral triangle, because this length is root 2 to the power 1/3. This length is root 2 to the power 1/3, because that's the modulus of these complex numbers, and even this. So what I can do is I can use one of this triangle to find out the area of this entire equilateral triangle, because I know this angle is 120. This is root 2 to the power 1/3. This is root 2 to the power 1/3. So I can just find out the area of the entire triangle by finding the area of the one of the triangles, you can see clearly here. And so it's like half A B sine C and multiply that by 3. So I hope this is helpful lesson, and this is something that you wanted help with.